All right. So you want to get out your power chart from yesterday. So today we are going to solve exponential equations. We're on page 13 of our notes, page 13 of our note packet. So today we are solving exponential equations. And the method that we're going to use today is called method of common bases. So we're just going to look for common bases. So remember, when we have an exponent, if we have a number raised to the power, the number that's being raised to the power is called the base. So we are going to, using our power chart, using our little power chart that you guys made yesterday, we are going to solve these exponential equations by putting both sides of the equal sign into a number that has common bases. So here's kind of the way I want you to think about this. 2 and 16 can both be written as a power of what? So if you look at your power chart, 2 is not a power of 4. Well, technically it could be a power of 4. Yes. But like if you look at your power chart, 2 to the first power is 2 and 2 to the what power is 16. 2 to the fourth power. So 2 is the same thing because it's 2 to the power of x. First thing that we're going to do is replace this 2. So 2 to the first power, exponent on the outside, x equals 2 to the fourth power. Now, 2 to the first power and 2 are the exact same thing. There's a reason why I'm doing this. It's because I want to remind you that back in Math 1, probably even before that, you guys learned this rule that says if you take a power to a power, meaning if you have a number raised to a power with an exponent on the outside of it, you multiply those two things. Do you guys remember that? Okay. So x times 1 is just x and equals 4. So once your bases are the same, you kind of ignore them and you just solve it like that. So let's do it again. Tell me about 3. 3 is just 3. We're going to leave it alone. What about 27? 27 is the same thing as what power of 3? Look at your power chart. 3 to the what? No, 3 to the 9th power is not 27. 3 to the third power. 3 to the third power. So once your bases are the same, do you guys see that I have 2 bases that are the same? Once your bases are the same, you just get rid of them and you solve the exponents like an equation. So we're going to get rid of the bases and we're just going to solve this like an equation. Well, it's already solved for us. The first couple are already solved for us. Does this make sense what we're doing? Okay. So example C, we have to write 1 over 25 as a power of 5. So I'm going to put a little note up here that says 1 over 2 squared is the same thing as 1 over 4. But when you first learned how to write this, it was presented like this, 2 to the negative 2 power. Someone tell me about negative exponents. What'd you guys learn back in your early days of math? Are you allowed to have a negative exponent? Can you leave your answer with a negative exponent? Yeah, it's not allowed, right? It's technically not allowed. So the way that I explain it is kind of like this. If you have a negative exponent, think about being on a bunk bed. So this is a whole number, right? So this exponent is negative and it's in the top bunk. The only way that I can make this exponent positive is if I move it down to the bottom bunk. Now it's positive and I have to put something upstairs. So really the 1/4, which is the same thing as 1 over 2 squared, started as 2 to the negative 2 power. So look at example C. 1 over 25 actually started as 5 to what power? Yeah, 5 to the negative 2 power. Good job, sir. So are my bases the same? Yes. So I'm going to ignore the bases and solve the exponents as an equation. X equals negative 2. And again, these first couple of examples, X is all by itself. So there's really no solving. Okay. What about number 16 or D? What can I say 16 is? 16 is the same thing as, do you want to write it as a power of 2 or a power of, that's the whole number 16. So you can write it as a power of 2 or a power of 4. What do you want to change 16 to? Let's decide first of all, do we want to write it as a power of 2, 2 to some power, or 4 to some power? 2. Okay. So 16 on your power chart is the same thing as 2 to what exponent? 2 to what power? 2 to the 4th power. Okay. But remember, you have an x outside of that, so you have to bring it down. And 4 is the same thing as 2 to the 2nd power. Do we see that? You see what I've done? I've just replaced the number 16 with 2 to the 4th and the number 4 with 2 squared. So now I have to use that rule that says if I take a power and raise it to a power, I have to multiply those two exponents. So what is 4 times x? Okay, so really on the left side, I have 2 to the 4x power equals 2 to the 2nd power. Are my bases the same? Yes. So I'm going to ignore the bases, and I'm going to solve the two exponents like an equation. 4x equals 2. Divide both sides by 4, which means x equals 1/2. What are your thoughts? Okay. So all example 2 says all of this whole exercise is just reminding you of the law that we just used. It says, hey, I want to remind you that when you take a power and you raise it to a power, you have to take the two exponents and multiply them together. So 2 cubed to the power of x becomes, anyone? What do I do with the two exponents? Yeah, it would be 2 to the power of 3x. Thank you very much. Okay. So I have 3 squared raised to the power of 4x. So I have to take these two exponents and multiply them together. So this becomes 3 to the, 3 to the 8x power. Good job, you guys. Okay. So now I have a grouping, right? So we're going to have to do a little bit more than just multiply straight up. We're going to have to distribute, right? Because I have the -1 inside multiplied by 2 terms on the outside. So once I distribute that -1 or multiply both terms by -1, I end up with 5 to the power of, what's -1 times 3x? -3x plus 7. Thank you. Chris, are you with me? Pick your head up so you know that you're awake. You got to fill out your notes. Okay. Example D. Again, I'm taking the power on the inside and I have to multiply it by the power on the outside, but that power on the outside is joined by an addition or subtraction. So we're going to have to distribute. So this becomes 4 to the -3 times 1 is, and -3 times -x squared is +3x squared. Good job. So that we're just making sure you understand the rule to simplify before we solve exponents that look like that. Are we good? Okay. So now it says, hey, now that you know that rule of raising a power to a power, and you know that sometimes you might have to distribute your exponent, now we're going to actually get into the whole like solving equations. So we have to take both numbers, the 8 to a power of x and the 32, and write them with a common base. So if you look at your power chart, in what column do you see the number 8 and 32? If you have your power chart filled all the way out, In what column do you see the number 8 and 32? In the 2 columns, right? So 8 is the same thing as 2 to what power? 2 to the third. Okay, and I have to remember that it's being raised to the power of x on the outside. And then 32 is the same thing as 2 to what power? 2 to the fifth. And I'm not taking 32 to anything, so I don't have a power on the outside of that. So when I distribute, I really have 2 to the 3x equals 2 to the fifth. Are my bases the same? So once your bases are the same, you ignore them and just solve the exponents. 3x equals 5. What do I do next, David? Yeah, divide both sides by 3. So x equals 5/3. Now, you know what? That's really crazy. I just don't even believe that. So can we put that into a calculator to check it? So can we take 8 to the power of 5 divided by 3? And if we did this right, what's it going to equal? Good job. Did we do it right? Yeah, we did. Okay. All right. Example B, looking at your power chart, what column has both the numbers 9 and 27 in it? 3. So we have to write both of these as a power of 3. So 9 is the same thing as 3 to what power? 3 squared. And I have to bring this down to the outside. It's all right, Lamar. They're not coming to get you. You'll be okay. And 27, he's just so distracted by looking outside. 27 is the same thing as what? 3 to the third. Okay. So what do I need to do over here? I have to distribute that, right? So 3 on the left becomes 3 to the 2 times 2x is, and 2 times 1 is, equals 3 to the power of 3. Are my bases the same? So ignore the bases and solve the exponents as an equation. 4x plus 2 equals 3. So what do you want to do next, Fallon? Yeah, let's subtract 2 from both sides. 4x equals 1. Chris, what do you want to do next to get x all by itself? You always divide by the number attached to the what? The variable. So we're going to divide both sides by what? Is 1 attached to the variable? The answer is not going to be 1. What number is attached to the variable? What number is that? 4. So we're going to divide both sides by 4. So x equals 1/4. X equals 1/4. I'm going to check this, and I'm just going to kind of check it mentally. So let's see. 2 times 1/4. 2 times 1/4 is what? 0.5 or 1/2. So what's 0.5 plus 1? So what is 9 to the 1.5 power? Okay. Do you guys see how you can check it quickly just to make sure you're doing it right? Okay. Example C. We're going to write these both with a base of what? 5. So 125 is the same thing as 5 to what power? So 5 cubed with an x on the outside. And what about 1/25? Yeah, that's the same thing as 5 to the negative 2 power. And remember, that's also to raise to a power of 4 minus x on the outside. 4 minus x on the outside. So both sides of our equal sign are going to require us to do some distributing, right? So on the left, 3 times x is Good. And on the right, negative 2 times 4 is, and negative 2 times negative x is. Okay. Are my bases the same? Yes. So I'm going to ignore the bases and solve the equation as normal. So what do you want to do first? Perfect. So when I subtract 2x from both sides, I have that x equals negative 8. X equals negative 8. I'm going to check that in my calculator. I'm going to see if 125 to the negative 8 power is the same thing as 1 over 25 raised to the 4. Let's see. Minus a negative would make that 4 plus 8, or 125 to the 12th power. Who's checking that for me? I'll do the 125 to the 12th power. Someone else needs to do the 125 to the negative 8. (1.677216) to the negative 17th power. And that's exactly what I got for the other one. So as long as, and so when you get crazy answers like that, just make sure that they both match, right? So we're right on the money. Okay. Now, do you have to check all of these? No, but it's really beneficial to know how to check them. Super helpful to know how to do that. Okay. So we have one more example in our notes. So it says, if the following represents, which of these choices down here represent the solution to this? So I'm going to kind of slide over, so I don't really care about the choices yet. I want to solve it. So I have 2 to the power of x squared minus 3. That means I need to rewrite 64 as a power of 2. 2 to the what? Yeah, say 2 to the 6th power. We're not going to just say things like 2 6. That's not how we say that. So are my bases the same? So ignore your bases. So I have x squared minus 3 equals 6. What do you want to do, Keegan? Add 3 to both sides? Okay. So what is the square root of 9? So do you get, the last time we did something where we had to take the square root of both sides, I said to you guys, when you physically draw a radical sign, like when you physically draw the square root sign, that means that you have to remember that there are 2 roots, right? A positive and a negative. Yeah. So that means that x equals a positive or a negative 3. And I'm going to check it really fast just because I want to make sure. So if I were just to do a real quick check on this, positive 3, let's see, 2 to the 3 squared is 9 minus 3, which is the same thing as 64, 2 to the 6. So it works when I use the positive 3. What about when I use a negative 3? What is negative 3 times negative 3? It's positive 9 minus 3 also equals 2 to the 6. Okay. So you have to remember that it's when you physically draw your own square root symbol, you're using both the positive and the negative roots. So your answer choice is 1. Answer choice is 1. So if you don't have your power charts filled out, you should. You should absolutely fill those out. I am going to walk around and here's what I'm going to do. 1, checking your power charts. I told you guys you would get 3 points for that, right? Checking page 1 through 4 from Friday. That was our Friday assignment. Worth 10 points. And then I'm checking your pages 5 through 8 from yesterday because I didn't check those. And I'm going to go back to the module as soon as everybody's done writing down their notes because I want to show you that really yesterday when I assigned the pages 11 and 12, did anyone look at the agenda and see that really I wasn't supposed to assign that till today? Yeah. Why didn't you call me out on that? Feel like you can do that. I'm the one who actually wrote that agenda because it was my turn, right? So yeah, feel like you can say, this is so much stuff. So if you don't have 11.2 done, that's fine. I do have the answers posted to the 1.4 yesterday and the 5.8 today, and I'll post the 11.2 to the pages 11 and 12 tomorrow. Sorry. Yeah, feel like Mrs. Bischoff, you need to read this. You're like way off. That's okay. Right? I mean, don't call me crazy, but you can definitely call me out for sure.